Hello everyone, welcome to the session once again. This is live session for the week 5. The course is Introduction to Accounting and Finance for Civil Engineers. The course instructors are Professor Sudhir Mishra from IIT Kanpur and Professor Kenja from IIT Delhi. I am Venugopal Mahajan, a research fellow at IIT Delhi. So coming to the contents, this is the list that we have completed till last session. We have studied risk analysis manually. Now in this session we'll be seeing simulation, Monte Carlo simulation. This name might be familiar with most of you, not only because of simulation but also because of the uh, what you can say casino city. And we'll be discussing the uh, bidding. Bidding is very important topic for civil engineers, but in this session we'll just be covering some basics because the next session would uh, solely discuss the bidding part only. So uh, coming to few numericals, these numericals, um, some of these numericals are from continuation of the previous session, and some of these are directly from previous year's assignment and some modified questions. So this question we solved in the last session also, that if you have been given the years of life and probability of obtaining that life. Uh, the question is the probability that a machine will last a certain number of years. Okay, so what is the expected life of the machine? If the question had stopped till here only, like what is the expected life of the machine, we would have just gone by pi into yi, right? Probability of each outcome into the value of outcome, summing it up. Last time we got the value as 12.15 years, right? So now let's see what happens when we perform 10 trials. 10 trials. So performing it randomly, what I have got from Excel is some random values from 1 to 100. It can be 0 to 99 also. As you can see that there is no fixed pattern. If you go either vertically or horizontally or any other direction, you can't find any. uh, just a moment please. Hmm. Hello. So I will be repeating the question. The probability that the machine will last a certain number of years is tabulated. What is the expected life of the machine? So we have got random values between 1 to 100. We will be performing 10 trials. So as you can see that there is no series 23, 85, 56, 86, 3, 95, 64, or even if you go in this direction 23, 66, 92, 15, 56, 3. Okay, so no series at all. Now let's do our trials. Are you following what is happening? See, this is a live interactive session, and for the benefit of both of us, it would be uh, quite good if you reply or if you participate in the class. You can hear me and see me clearly, right? Me and my screen.
Yes, sir.
Okay, thank you. Uh, Please try to participate. Okay, so coming back here, so let's start doing the trial. Then there is random number. Then what should be the years? Okay, now for the first trial, let's suppose we are going horizontally starting from 23. Random number is 23. But uh, how to add the how to see what number of years is does this signify? So what we do right here is that from the probability we find cumulative probability. This is in order only. So let's just add things up. 0.35 0.35 plus 0.25, that gives 0.6, 0.8, 0.95 and 1.0. our random values are between 1 to 100, right? So let's give this the range 1 to 100. So this will be 1 to 15, 16 to till 35, right? 35, 36 to 60, 61 to 80, 81 to 95, and 96 to 100. So from these, let's start giving the values. For 23, the value we get is 23 lies 16 to 35, that means 11. For second, we have got 85. Let me just make the list and then we'll start putting the values. For 3, we have got 56, 86, 3, 95, 64, 51, 26, and then again coming back 9 values, right, in one line. So 66. And respective years, what we get is for 85, we get 14, right? For 56, 12, 86, 14, 3, we get 10, 95, 14, 64. For 64, what value do we have? 13, right? For 8, no, sorry, for 51, we have got 12, right? And for 26, we have got 11. For 66, 13. So what is the average here? Let's sum it up.
सर
Yeah.
रिपीट करना ईयर का कैलकुलेशन कैसे आया?
ओके, सो हमने क्या किया कि हमें प्रोबेबिलिटी दी हुई थी 0.15, 0.2, 0.25, 0.2, 0.15, 0.5. जब इसका टोटल करते हैं, इफ़ यू सी इट इज़ 1, राइट? अगर सम ऑफ प्रोबेबिलिटीज
हाँ
1 है, इसका मतलब जितने भी पॉसिबल आउटकम्स है वो हमने कवर कर लिया, राइट? सो जितने भी पॉसिबल आउटकम्स हैं वो अगर हमने कवर कर लिए, सो वी डिड क्यूमुलेटिव, कि हमने क्यूमुलेटिव असेंडिंग ऑर्डर में ही था, हमने ऐड कर दिया 0.15, 0.35, लाइक 11 ईयर्स या उससे कम की प्रोबेबिलिटी हमारे पास कितनी होगी? 0.15 प्लस 0.2, 0.35. अब जो क्यूमुलेटिव हमारे पास बना, उससे हमने रेंज बनाई. अब रेंज बनाने का तरीका, हमें जो रैंडम वैल्यूज़ दी है वो है बिटवीन 1 to 100. सो फ्रॉम दैट वी मेड द रेंज 1 to 100 विद द प्रोबेबिलिटी डिस्ट्रीब्यूशन दैट इज़ गिवन. और ये रैंडम नंबर्स के साथ हमने रैंडम नंबर्स की लिस्ट बना ली 1 to 10, बिकॉज वी हैव टू परफॉर्म 10 ट्रायल्स. और उन रैंडम नंबर्स को, जो उन रैंडम नंबर से एसोसिएटेड जो ईयर्स थे वो हमने चेक कर लिया. लाइक फॉर 23 वी हैव गॉट वैल्यू 11. फॉर 85 lies in the range of 81 to 95, so we got 14. So do you follow now?
ओके सर समझा. यस सर गॉट इट.
Okay, so what would be the average here? Right, it would be the sum of these values. So can you sum it up with me? 5, 6, 7, 11, 15, 18, 20, 24.
12.4.
Okay, 12.124. So it is coming as 12.4. So you see that at 10 trials, you are getting the value of 12.4, while when you did it for probabilities as expected value, you got 12.15. So two different values. Which one is correct? Okay, I will let you think about this, and we'll see this in another example also. So now you know how to assign the range and find out the values. So this is a modified question from a previous year's assignment. So let's see. I mean, this is kind of a lot of information in one question. Transit mixers arrive at a batching plant from different sites in an area served by a common RMC. The arrival time intervals of transit mixers are observed and yielded the following results. So what you have got is that there is one person sitting at the gate, and he notes that uh, after 2 minutes, uh, he just starts recording the number of the time between the arrival of transit mixers. So let's say there is one transit mixer entering and then the another entering. So he records the time that, okay, 10 times this interval was 2 minutes, 30 times this interval was 4 minutes, and so on. Now let's again check if this is the complete distribution. As you can say that 15 plus 10, 25, 25, 50, 100. So yes, this gives you the complete slot. Then there is some other information. Time taken to load the transit mixer uh, is which have either 6 or 9 cubic meter capacity are fairly constant at 4 and 7 minutes respectively, and both types are equally represented at the depot. So what the person notices is that there are two types of mixers, transit mixers coming. Either they have 6 cubic meter capacity or 9 cubic meter capacity, and the time taken is that they take either 4 minutes for filling or 7 minutes, and they are equally represented. So if they are equally represented, what is the probability? You can say it is 0.5 for both, right? Okay, so now what you have to do is start the trial from 9 a.m. and assume there is no mixer waiting at this time, and you have been given some random numbers to use. So you have to answer the following questions for first 6 trials. What is the total time likely that the batching plant will be waiting? Sorry. What is the total time likely that the transit mixers will be waiting? Maximum number of transit mixers waiting at given point? And what is the profit in first 6 trials? Is the question clear? What is
Yes, sir.
Yeah. So what should be our first step here? What should be the first step here? The first step should be to generate the range. I mean, we have got probability distributions. So now let's find out the range, right? So let's do it here itself. Uh, Cumulative frequency in this case would be 10, 25. This would be, wait a minute, 55, 80, and 100, right? So similarly, range would be, as you can see, we can take either 0 to 99 or 1 to 100, right? It won't be changing much. It won't be changing anything here. Okay, so we'll take 0 to 99. So this becomes 0 to 9. This becomes 10 to 24, 25 to 54, 55 to 79, and 80 to 99, right? I mean, you can make this range. This is for one case. For what? Arrival time interval. Now what about the mixers 6 or 9? So you have got two mixers coming in, right? Mixer, time, capacity, because we'll need both, and frequency and range. So our time, we have got 4 minutes for 6 cubic meters, right? And 7 minutes for 9 cubic meters. Frequency is 50 for each, right? So from that you can write that 0 to 49 would be the first type, and 50 to 99 would be the second type, right? Do you follow till here?
सर समझ में आया लेकिन मैंने लिखा नहीं है रिटर्न में.
Okay. So let me just Okay, let me just turn off my camera. It will help me save the bandwidth. Okay, so till now in this question we have got two cumulative ranges, two cumulative frequency and two different ranges, and we have got random numbers, right? So now how to use it? As you can see that there is no connection between arrival time and mixer capacity. You can say that, right? I mean, अगर 2 मिनट में भी मिक्सर आ रहा है तो वो 6 क्यूबिक मीटर का भी हो सकता है और 9 क्यूबिक मीटर का भी हो सकता है. देयर ये दोनों डिफरेंट डिफरेंट इवेंट्स हैं हमारे लिए, राइट? सो लेट्स सी व्हाट वी डू इन दिस केस. So for trial 1, we'll be going horizontally, right? As we did last time. Yeah. So what was the first random number we had? It was 24. 24. So just give me a moment to delete this slide and delete the empty one. Okay, so for 24, you know that arrival time is 3 minutes. Now we are starting at 9 a.m., right? And no one is in the queue. So when does this arrive? This will arrive at 9:03. Now, what is the size of the mixer? You can see that what is the second variable now? 99, random number. 99. For 99, we have got mixer size of 9 cubic meter and fill time of 7 minutes. So, if fill time is 7 minutes, when will it be filled? If it is arriving at 9:03, it will be filled at 9:10, right? What is the wait time of the plant? You can say that 3 minutes. It started at 9, but the first one arrived at 9:03. So 3 minutes for the mixer. It arrived at 9:03 and it didn't have any wait time. Right. So, and Q, no Q here. Second trial, similarly, 17 and 20 are the two random numbers we have got. Wait a minute. Yeah. 17 and 20. So this would be 6,6/4 minutes. What about this for 17? Sorry. Again, the value is 3. So now when does the next mixer arrive? First one arrived at 9:03. So adding 3 to this value, right? So it is arriving at 9:06. Now what is happening? The mixer arrived at 9:06, but the batching plant is busy till 9:10, right? Do you follow this? I mean, it is still filling the first one. So if it is still filling, then it can only start filling the mixer 2 after this. And how long it will take? It will take 4 minutes. So it will finish at 9:14. So plant didn't have any wait time, but transit mixer arrived at 9:06 and started filling at 9:10. 9:10. So transit mixer waited for 4 minutes. Similarly, if you see the third case, yeah, third case, what values we have got? We have got 31 and 70. 31, 70, this means this is 7-minute one. And for 31, we have got 31 is in the range of this, so 4 minutes. Now the mixer arrives at 9:10 for, but the plant is free at 9:14 only, and it will be filled at 9:21, 7 minutes. So plant is not waiting, but the waiting time for mixer is 4 minutes. Yeah, so let's okay, till 70 we did. 1472 for the next set. 1472. For 14 we have got 3 minutes again, so it will be arriving at 9:13. 72 means 7 minute. 9:13 arriving at 9:13, but it will start only at 9:21, right? So filling at 9:28, and wait time is how long now? It is 8 minutes now. Similarly for fifth, what have we got? 96 and 43. For 96 it is 6 minutes, so it would be arriving at 9:19, and 43 means 4 minute. So 4 minute after 9:28, so it would be 9:32. Plant waiting time is none. For transit mixer it is arriving at 19 but starting only at 28, so 9 minutes now. For 6, 21 and 52. For 21 we have got 3 minutes, so it would be coming at 9:22, and 52 7 minute again, so it would be finishing at 9:39, and waiting time here would be 10 minutes, right? I'll deal with Q later. So can you follow how we made this table? Mm, okay. So for the guys joining a little late, just a moment, please. Okay, so in this session we are discussing uh, Monte Carlo simulation and basics of bidding. So this was our question. I'll give you guys a minute to read the question. Do you guys have any queries regarding the topics that we have discussed earlier, or any specific question regarding uh, bidding or Monte Carlo simulation? Okay, have you guys gone through the question now? I will need a yes to move forward. Okay, so in this question uh, we have got two different outcomes. I mean, two different things we are interested in: the arrival time difference for the transit mixers and their capacity. We had been provided with the frequencies, so we made the range, and from the random numbers given, we started assigning them the times, that when did they arrive and when did they filled. Do you guys want me to repeat this?
Yes, yes.
Okay. Uh, so just give me a moment. Yeah. So this was the arrival time given and frequency given to us. Frequency was 100, so the sum was 100, so we know that each and every outcome has been considered if we take 100%. So what did we do next? We converted into the range. How did we do that? We found cumulative frequency, then generated the range from 0 to 99. 0 to 9, okay, this should be 99. Similarly, we had been given that there are two two kinds of transit mixer coming, either 6 cubic meter or 9 cubic meter, and the filling time is 4 minutes and 7 minutes respectively. So giving them and both types are equally represented, 50% probability. So frequency is 50 each, and range we are giving at 0 to 49 and 50 to 99, each with 50 outcomes, right? And then we had to start the trial at 9 a.m. and assuming that no transit mixer was waiting at this time, and these were the random numbers given to us. You can see that there is no series in this case. I generated it using Excel. So we had to do 6 trials. So starting with the trial, for trial 1, what is the first random number we have? It is 24. For 24, if you go back and see, if you check in this table, for 24 we have got arrival time as 3 minutes. So I take at 3 minutes. So when does the transit mixer arrive? First one, we start at 9 a.m. So it arrives as 9:03. Now what about the size of the mixer and fill time? So we see that the second random number is 99. For 99 we have got mixer as 9 of 9 cubic meter capacity. So 9 cubic meter capacity, it will take 7 minutes to fill. So if we start filling at 9:03, so it will be filled by 9:10, right? Now in this case what happened is that the plant started at 9. So how long did the plant wait? 3 minutes. What about the transit mixer? It arrived on site at 9:03 and started filling because there was no queue, so no wait time. Similarly, moving on to the second trial. So now what is the random number? 17 and 20. I mean two tables, so two random numbers. 17, 20 for each. Arrival time for 17 we have got 3, and for 20 we have got 4 minutes. What about the arrival time now? So first one arrived at 9:03 after 3 minutes, so this one will arrive at 9:06. What about filling time? See, we can't just add, okay, it arrived at 9:06 and it will be filled by 9:10. 9:10, sorry. Why not? Because the first one is already getting filled now. So the second one is in queue for how long? For 4 minutes. After 4 minutes at 9:10, it will start filling, and at 9:14 it will be filled. Similarly, what about the third trial? 31 and 70. 31, so arrival time, checking here, 31 is in this range, so it will be 4 minutes. 4 minutes, so arriving at 9:10. It can only start filling at 9:14. Right? So again for this we have got 4 minutes of wait time, and it will be filled by 9:28. And similarly I made the whole table. You follow, so can you follow, have you followed it till now? Okay, so coming back to our questions, what is the total time likely that the bleaching plant will be waiting for 6 trials, and total time that transit mixer will be waiting? So you can see from here that plant is waiting only 3 minutes, and transit mixer, it is waiting how much? 16, 26, 35 minutes, right? Now what is the maximum number of transit mixers in waiting at a given point? So can you guys find that out from this table? Is there any shortcut to find it out, or you have to go minute by minute and check? Okay, any answer would be good now. Okay, I'll check only for the what happens at the arrival time. Okay, when the second mixer arrives at 9:06, it is in waiting, right? 1. What happens at 9:10? 9:10. This mixer has started filling, so again only one mixer. This one is waiting at 9:13. Now what happens at 9:13? still 3 and 4, 2 will be in the queue, right? When this one arrives at 19, so only fourth is in the queue, right? Because third is filling and this one will be in the queue, so 2. What about at 922? 922 you will see that fourth is filling, right? And fifth and sixth are in the queue, so 2. So you can say that the maximum so from this you can see that the maximum number of transit mixer in waiting at any given point of time, 2. Now the question is, the cost of raw materials is given, operating cost is given per minute, and selling price is given to you. So how to calculate the total profit? In this case it would be, let's see how much cubic meter of the concrete did we sell. So you can give that this is again 9, 6 and 9. So hello, can you hear me now? I think there was some network trouble.
Yes,
Okay, so do you follow what happened till now, and where was I when the network got interrupted? Okay, so what we did was we calculated the profit that was asked in question number 4. We had been given operating cost per minute, raw materials per cubic meter, and selling price per cubic meter. So we summed it up and calculated. Do you follow till now? Okay. Do you have any doubt? Okay, so similarly, moving on. Now, what we have seen till now were the examples that were quite not directly linked to economics and finance. So, coming to one example that you can find out that happens in real life, that we don't have some perfect probability distribution curve that we would like to assign some values, or we would like to solve the same problem for thousands of iterations to know that what should be the best expected value. So now in this case, what have you been given is that the initial cost of an equipment is rupees 30 lakh. The project's life is from a discrete uniform distribution that takes on the values of 7, 8, 9, 10 and 11 years. So you see that n is not fixed. We have seen this type of case, right, in sensitivity analysis also. The annual profit is uniformly distributed between 4.5 lakh to 9 lakh. So they're saying that you can have any value between 4.5 lakh to 9 lakh, and it is uniformly distributed. So it can be anything. What you have been asked to do is you have been asked to simulate for 5 iterations and determine the expected value of present worth. I has been given 8%. So now let's see what is happening. Discrete uniform distribution. So for all these, you have got probability of 0.2 each. But what about this? Uniformly distributed between 4.5 lakh to 9 lakh. So what you have got is, you have got a curve like this, 4.5, 9, and it's a straight line. Okay. So you have to determine the value for each outcome. You have been given the interest table also. What value would you use? We have to calculate present worth, and we have to find it respective to annual profit. So we'll be using P given A for the years 7, 8, 9 and 10, right? Till 11, right? So this becomes what we are interested in. Now, initially, if this question was given to you before the introduction of this random numbers or random values, what you would have done is you would have done it simply averaged out for n, which each being equal outcomes, 9 plus 10 plus 11 by 5, right? So this would have given you 9 years. Similarly for a, if it is equal distribution, so you would have gone for by 2, so find the value in the mid, right? 50% probability. Are you following till here what is happening? So are you following what is happening here? So this would have been 6.75 lakh, and finding the present worth, it would have been minus 30 plus 6.75 into p by a for 9, it would be 6.2469, right? And that would have given you the value of 12.17. But what you have been asked to do is you have been asked to do it for 5 iterations and determine the expected worth. So how would you proceed in this case? So just let's start writing. For what we would have is, we have to perform it for 5 trials. For each trial, let's write the random numbers first. 2385 will be okay. This time let's go in this direction. Okay, 23, 66, 92, 15, 23, 66, 92, 15, 56, 3, 35, 46, 56, 3, 35, 46, 74 and 53. So these were just the random numbers I noted down. Hope you followed till here. Now we have got probability distribution for these 0.2 each, 0.2 in 7, 8, 9, 10 and 11. So you can say that we can have the ranges for 1 to 100, 1 to 20, 21 to 40, 41 to 60, 61 to 80 and 81 to 100. So for this range, each 20 and starting from 7 to 11, right? So this will be 8, 11, 9, 8 and 10. Similarly, p by a values, if I note it down, I mean this is directly from the table, 5.746, 7.139, 6.247, 5.746 again, 6.710. Now how to determine a, that is the question. And why is this a question? Because you have been given a uniform continuous distribution, and this can be same as, like, instead of uniform continuous, you could have been given the normal distribution curve, right? Normally distributed with some mean and some sigma. So how to calculate in that case? Like for the first one, you have been given R2 is 66. 66 means what you have to do is from 1 to 100, at, if this is uniformly distributed, somewhere around 66 you will get value in uniform. This is uniform distribution. So what you have to do for calculating at 66, the value would be 4.5 plus 66 by 100 of 9 minus 4.5. And how much is this? This you will get around 7.47. Similarly, if you calculate for each of these, 7.47, for 15 it would be much nearer to 5, 5.175. For 3, closer to 4.5. I mean 4.5 our starting value, 1 to 100. So third part of that, very close to this, 4.635. For 46 we have got 6.57, and for 53, 6.885. So did you follow how we got these values? I am asking this because in the similar manner you will have to do if you have got any other type of distribution curve. Okay, so you have got this. Now what about the present worth? Present worth, you can write it as PW would be minus 30 plus A into P by, right, that we have got in this column. So from that you will get the value as 12.927. For this, 6.944 minus 1.046, 7.755, and yeah, 16.199. So average of these values of 5 iterations, you are getting 8.566, while initially you got 12.17, right? 12.17 by the initial methods that you learned, and 8.566 by simulation. So which of the above is the correct value? I mean, what would you take? You are getting two different values for same question by two different methods. Two different values, so it might be that one is correct and one is wrong, or one is more correct. What are your thoughts on this? Okay, if this is very clear to you, I will move forward. Or any other question in simulation part? Okay, it seems no question, so I will move on. So consider the following statements. We are now into the basics of bidding. In restrictive bidding, the first stage is pre-qualification of contractors. Statement 2, direct costs are nothing but all the project overheads. Which of the above statements are correct? Restrictive bidding, the first stage is pre-qualification of contractors. Yes. So that is how you restrict, you are not open to everyone. Direct costs are nothing but all the project overheads. No. When we are talking about direct costs, it is the labor cost, the material, the equipment cost that we are calculating. So as statement 1 is true. Now coming to this, if the markup is 10% of the bid price, then the bid price in terms of total cost is given as P is equal to 0.9 T. So now let's see what the markup is, what the bid price is, and what the total cost is. Let's say that the total cost is T. Okay, so you have got some profit on this, and this will be your bid price, right? Bid price. Now this profit can be a percentage of your total cost, or it can be a percentage of your bid price itself. What you have been given is that this markup is 10% of bid price pre. So T plus 0.1 P is equal to P. So that means that gives you that your total cost is 0.9 P. But what you have been given is P is equal to 0.9 T. So this is wrong. For comparable bidders, the difference in bid price is mainly due to their differences in markup. Okay, so first of all, comparable bidders. What are comparable bidders? You can say that uh, the companies that are in the market, they have been there for quite some time, so they know they know what the total cost of the project would be, right? If they are executing the project. Now, calculating this as estimation process, and you have to be very good with your estimates for calculating the total cost. Now, if these companies have executed quite a handful of projects, so they know how to accurately estimate or how to very closely estimate their total cost. So, but still their bid price is different. How? So that means they are changing their markup, right? So statement 2 is correct. Okay, so now coming to the next part, choose the correct option. Markup can be expressed in terms of some percent of bid price. Yeah, we have seen that. In terms of some percent of direct cost, not direct, some terms of indirect cost, no. Project overhead, no, we have seen that it has to be total cost. So we have been discussing total cost and bid price, markup. So what actually is included in all these terms? Let's discuss that. Okay. So bid price has two components, as we saw. Total cost and uh, markup, right? What about total cost? Now, total cost can be direct or indirect. So, what are the direct cost? That uh, labor, equipment, then what else? Material, and okay, some subcontractor if you are paying. What about indirect cost? Project overhead, right? Uh, Overhead, and obviously your profit also. Profit will go here. No, profit is in your markup. So what will come here? What is the indirect cost that is remaining now? There would be some common P&M you're using, right? And some workmen. The indirect cost that you cannot directly link to, you cannot attach directly to any activity. What about markup? Profit. What else? If there is some risk, so you have to cater for that risk, right? Okay, so now coming to the calculations. For a building project, the estimated total cost is rupees 20,000 and the bid price is rupees 25,000. Consider the following statements. The markup is expressed in terms of percent of total cost is 25%. The markup expressed in terms of percent of the bid price is 20%. Now, uh, so what you have got is T is equal to 20,000, P is equal to 25,000. So what is your markup? 5,000. Okay, so in terms of percent of total cost, for total cost it would be 5 by 20 into 100, right? So 25%, right? In terms of bid price, it would be 5 by 25 into 100, so 20%. So both of these statements are correct. Coming to the next part, For a building project, the estimated costs of different items are given to you: civil, electrical, firefighting, and plumbing. So, direct costs. Okay. Then the cost of common plant and equipment has been estimated to be 1000. So, indirect cost is given to you. Further overheads is this is also indirect cost. What they have given you is that there is no escalation clause in the contract. Why do you need escalation clause? First of all, see, the project duration is 30 months, so you can't say that the cost what at which we are purchasing the equipment, or what the labor is charging you, or the purchasing the material, it would be same towards the end, or in the whole duration of the project. And in our case, India being a developing country, and you all are familiar with the term inflation, so you know that okay, there is going to be some escalation. What generally happens is that in contract condition itself, they have some escalation clause that, but in this case there is no escalation clause. Now, who will bear the cost of escalation? Obviously, contractor is not going to pay from his own pocket, right? I mean, each and everything that is there, and if client is paying, so contractor will be charging this towards the client, right? So what he does is he estimates that okay, if the price is going to escalate by this percent over the complete project duration, so how much my cost will increase, and by that he calculates that okay, he has estimated that the escalation is somewhere around $5000. Now you have got this value. What is this escalation? So you can say that this is indirect cost. I mean, you are not attaching it to the to some specific activity, or but you are attaching it to the whole project, right? So now let's sum it up. What about your direct cost? You have got 230 plus 20 plus 15. Okay, this is your direct cost. What about indirect cost? 1000 for P&M plus overheads is 25. Okay, we are rounding it off to 1000, right? So 1 plus 25 plus your escalation 5. So what is your total cost? Total cost would be sum of all these, right? So this becomes 250, 260, 290, 306, right? So your total cost is $306,000. Now, what will be the markup amount if contractor desires to operate at 15% markup on his bid price? So what you have got is T. So let's write it in terms of formula. T plus 0.15 P is equal to your bid price, right? So what you are interested in, let's find out the bid price first, and from that we can calculate, right? So that means that gives you a 0.85 P is equal to T. We have got T is equal to 306,000, right? So that means your bid price becomes 306 by 0.85, right? So this is somewhere around I mean, calculating it, 360. Yeah, 360,000 dollars. If your bid price is 360, so what is your markup now? 15% of P. 15% of 360 is 54,000. So that becomes your markup. Uh, so I'm ending this lecture right here. Thank you.